being able to work with data from any system is important. Here, for example, we're going to show you what it looks like to import a DWG file into TopSolid'Wood and then turn that DWG file into a powerful 3D design. Here, you can see the data as imported. We have plan views and we have some side views, and basically what we want to decide is which of this data is the data we want to work in. We're going to get rid of all that up there and we're going to focus on the section down below. To begin with, we're going to transform this data and just move it over to our 0 point, and you'll see why in a little bit. This will make modeling a little bit simpler. So here we'll go ahead and say move from the center of that to 0, grab everything, and we're done. From here, let's start to try and extrude some elements. And as you can see, the curves came in, but they're just individual curves, and the software has no way of knowing what curves belong to what. So here what we're going to do is ask TopSolid to automatically try to recognize these profiles. Like that, it was able to create 11 closed profiles automatically for us. Now we can go select them and make our extrusions as needed. Now, just so we know how far we need to go with some things, we're going to add some basic reference dimensions. This is just to help us know what we need to do as we turn this flat 2D drawing into a parametric design based on these profiles. Here we're going to make a parameter, and this parameter is going to be called L. It's going to represent the length of our extrusions. And you'll see we're going to reuse this L parameter all over the place during this design. So let's start by extruding that. And here we're going to make it a centered extrusion and make it equal to L. And we'll do the same thing here. Centered equal to L, centered equal to L. Perfect. Now let's take that profile, and what we're going to do is we're going to offset its start position to be half of L minus 65 millimeters, and then we're going to extrude for 65 millimeters. Perfect. We're going to do the same thing with this board here. So again, half of L minus 65. And like that, we're quickly recapturing this design in full 3D. Perfect. Do the same thing with this support down here. And this one over here. Make it equal to the length of that one. We'll do the same thing with this board here. And so far so good. Let's get these poles as well. Do the same thing with this one here. So hopefully you're seeing that you can quickly reuse this simple flat 2D geometry. Outstanding. I think we have a couple more ones to do here. We'll do that one, and we'll do this one here. So like that, we've recaptured a good amount of this design. Perfect. Now the rest of it should be symmetric, so we should be able to just go ahead and duplicate using the proper symmetry planes. So for example, we can mirror about XY to get that one. And then we can mirror about YZ to get these three over here. That, and that. Perfect. Do another mirror about XY to get that. Outstanding. So, in a few minutes, we've taken that imported DWG data, recaptured it, and made it smart. And now, we're going to convert these all into wood parts so that we can create a bill of material of them down the road when we're ready to manufacture. So like that, you can see it inlaid over the 2D design. Everything's perfect. And then we can test it. Remember that parameter L? What happens if we make it 1800? And like that, everything's up to date. How about if we make it 500? You get the idea. We'll set it back to 1200. Okay, so we've created in another design the roof section that attaches to this. And you can see that here. And the reason we created it as another design is because this way we can test it in our assembly. So we have built or added that roof design to this design using a bottom-up assembly strategy. You can see it looks perfect. And moreover, we can test it. There's supposed to be a degree of freedom there, and there is. That's perfect. It's an advantage of using bottom-up assemblies. It almost doesn't seem fair to other 2D based systems because real quickly we can take something and turn it into a 3D design very, very quickly and efficiently. For example, we just made a simple pattern of that. Like that, all of our supports are done. Maybe now what we want to do is take that, around that, and revolve it for 360 degrees. Let's do that again. And like that, we're done. It just doesn't get easier. Now, let's see what happens when we put it all together. So here we're going to do a bottom-up assembly of everything we've done to date. We're going to start by locating that right at our 0. And you can see here, you have the entire roof design done there. We can repeat this, maybe via a simple mirror, so we have 2 of them. And now let's go ahead and include another component. Let's include the side. And here we just want to position it on that face. We want to take that face to that bottom face. And then I think we'll flip this over and we'll see if we can line up some of the edges. So let's take this edge here to that edge right there. Beautiful. And then we can of course just go ahead and mirror it as well. And like that, we're almost done with our assembly. Now we just need to put the base on, and here we've predefined some key points for positioning. So we'll just locate it right on there. Say OK, and we'll do that a couple more times. We'll put this one on here, and we'll repeat that via mirror as well. And like that, our fruit stand has been designed, and this is all based on recapturing the information from that imported DXF file. Let's have a look. You should get a good feeling that by using TopSolid, you can recapture the design and make it super smart so that you can take this design and automate its manufacturing process down the road. Here we'll change it to 1500, and like that, everything updates perfectly. Cool. The last thing to talk about would be the automatic bill of material.